Hello everyone, welcome to Engineering Archives. Now we will look at our learning problem number 2 for the chapter Coplanar Forces. So this question says, determine the magnitude of the resultant force in its direction theta measured counterclockwise from the positive x-axis. Before we get to solving this problem, I would like all of you to please read these 4 steps that we will be following in these general sort of questions that ask us for the magnitude of the resultant force and its direction. So the first step would be to add forces in the x direction, then add forces in the y direction, then use the resultant force formula to get the magnitude of the resultant force, and finally we can get the angle by using the vector triangle. So let's start solving this question. First of all, let's put down the directions. So from the question that we can see that they have given us all the forces that we need, but they haven't given us the angles that we will need to resolve the forces into their components. But we can use these triangles to find those angles. So let's do that. Tan of theta would be equal to 3 by 4, and theta would be equal to tan inverse 3 by 4, which would be equal to 36.87 degrees. Now from the diagram we can see that this angle is equal to this angle. Also notice that the direction of the force F1 is towards the 4th quadrant. So we can draw this vector in the 4th quadrant like this. And we know the angle that it makes with the x-axis, which is 36.87. So now let's add the vector components along the x-axis. So 15,000 cos of 36.87 plus 15,000 cos of 36.87 will give us 24,000 newtons. Adding components along the y-axis will give us 15,000 sine of 36.87 plus 20,000 minus 15,000 sine of 36.87. The components of the two 15,000 Newton forces would cancel each other out, leaving us with 20,000 newtons directed upwards. Now that we have the sum of all the components in the x and the y directions, we can use the resultant formula to find the magnitude of the resultant force, and that would be equal to 24,000 whole squared plus 20,000 whole squared square root, and that would give us 31240 newtons. So this was a simple procedure to find the magnitude of the resultant force. Now all we need to do is find the angle theta. I'm going to use this space right here to find the angle theta. So we need to draw the vector triangle. The sum of our components along the x-axis give us 24,000 newtons towards the positive x-axis, while sum of our components along the y-axis give us 20,000 newtons upwards, and our resultant vector is 31240 newtons. So to find this angle theta from the positive x-axis in a counterclockwise direction, we will simply do tan of theta should be equal to 20,000 divided by 24,000 and theta would be equal to 39.81 degrees. So this was the simple procedure for these sort of questions that ask us to find the magnitude of the resultant force and the angle. Thank you very much. See you in the next video.